Hello, everyone.
Hello.
Justice.
Good afternoon, everybody.
Hello.
Hi.
Hi,
Okay.
Pauline.
Colin, good to see you. It's been a while.
Yeah, it's been a minute. Are you good?
I'm doing very well, thank you.
That's good to hear.
What day is it today?
Thursday the 10th.
Thank you. Has been that kind of day. Okay. Welcome to the Technical Steering Committee. While we wait for people to file in, please familiarize yourself with our antitrust policy, in particular this notice. Linux Foundation meetings involve participation by industry competitors, such as all of yourselves. It is the intention of the Linux Foundation to conduct all of its activities in accordance with applicable antitrust and competition laws. You can read the rest. And if you have any questions, please check in with your individual legal counsel. Let me make this bigger on this side so that I can see everybody nicely on one screen. Hello, Matt. Welcome.
Thank you. Good morning from Seattle.
And good afternoon, good evening from Johannesburg. Okay, just bear with me a second. Okay, thank you. Right. On our agenda for today, let me just double check. Okay, so we will do a presentation on the rollout of the CI/CD issues and everything else at the next week's TSC. Scott is wrapping up his paternity break. So for those of you who do not know, Scott and his wife recently had a baby. So Scott is helping his wife get the baby settled. So at our next session, Scott will be available to do the working group feedback on the CI/CD. So on our agenda for today, we are just going to quickly review the multi-tenancy implementation. At our previous session, we discussed the overall requirements for multi-tenancy. We have since created the user stories for all of the functional requirements for the multi-tenancy as well. That is something that I would like to just walk through with our audience today so that we can brief everybody on the approach. So I'll be sharing that for today as well. And I think let's get right into that. So just one additional issue. When we discussed the setup of Keycloak in our slightly deeper investigation of Keycloak, we realized that what we were talking about as client groupings are in fact just groups. And these are groupings, and then within those groups, there will be subgroups where you can group a specific tenant into their own group. We reviewed the implementation of Keycloak as far as realms are concerned. So in theory, you could also create a tenant per realm. What we discovered, unfortunately, is if you do that, then each tenant will have its own realm-specific authentication endpoint, which would then have resulted in quite an invasive change to our authentication subsystem and pattern. So we felt like what we would rather do is to maintain access to Keycloak through a single authentication endpoint that works with our current authentication service, and then use the group structure inside Keycloak to be able to separate the tenants from each other. So what would then happen in this case is a particular tenant would issue when you sign on as that tenant, that group would be identified via a tenant identifier. And when you then authenticate yourself with the Tazama services, you would submit that tenant identifier to be able to tag all of your work inside the system according to that particular tenant ID. So what I'm going to do here is just quickly walk you through the high-level changes that we are proposing to make to the system here. So as you might remember, we have two organizations. We have the FRMS COE organization that hosts all of the private rule processors. And then we also have the Tazama LF organization that hosts all of the public processors. We have created a project in either one of these to contain all of the work, so you're free to have a look through and review this if you would like to see the detail yourselves. But each of the processor components in the core Tazama system need to be updated to accommodate multi-tenancy. There is not a single processor in the system that is going to be spared a update. So this is a fairly invasive change. It is also, as a warning for anyone who is currently working on Tazama or implementing Tazama, it is going to be a breaking change. The way that you are currently interacting with the system from a front-end perspective may be reasonably seamless, but if you are acting or using any of the internal Tazama services, and especially the inter-services data flows, those will undergo a change. So all of the payloads are going to be different in order to be able to separate the data between tenants.
Hey, Justin, did you see Fully's chat there? Oh, you can see them. He's just blunt. All right.
Okay, let me put that over there so that I can also thanks, Foley. Okay. Yeah, this should actually not have been a private project. I don't know why we made it like that. Hang on. That's probably a good point. You should have been able to see it because you do have access to everything in the system, but there we go. It is now no longer a private project. Thank you very much for pointing that out, Foley. Right. So end-to-end in the system, just as a quick recap, we receive transactions via the Transaction Monitoring Service API. Let me actually quickly find that so that we can walk through the end-to-end process so that you can just quickly get a visual anchor for the conversation. Right. So we receive transactions via the Transaction Monitoring Service API. The event director then routes those transactions to rule processors based on the transaction type. Rules are evaluated and send their results through to the topology processor. Topology processor results go through to the transaction aggregator that then combines a final result that is reported into the case management system. So across this value chain, all of these components are going to change. Starting here with the Transaction Monitoring Service API, just as a high level here, the first thing that we need to do is to update Keycloak. So inside Keycloak, as I already mentioned, you would have to issue a tenant ID to anybody who is authenticated with the system. We also have two modes of operation for the transaction monitoring service at the moment. You can run Tazama unauthenticated. That is usually done for testing and for demo purposes. We don't demo the system with a fully functional authentication subsystem, so there is a switch or an environment variable that you can switch on and off for deploying the system without the authentication subsystem enabled. The challenge we had here when we were going through the functional detail is we actually don't want the system to differentiate between a multi-tenanted and a single tenanted operation. And what I mean by that is, if you are running the system for a single tenant, that is effectively a multi-tenanted implementation of the system with just one tenant. It makes it a lot easier to consider the system then multi-tenant capable in every instance, rather than trying to cater for a system that is single tenanted or multi-tenanted. So going forward, Tazama is always going to be deployed multi-tenant capable, but may sometimes just have a tenant of one. And I quickly just want to pause there and make sure that everybody is comfortable with that as a concept, because that concept pervades all of the functional design and requirements around multi-tenancy going forward. Does that make sense? Everybody happy with that?
Yeah.
Okay, perfect. So that solves half of the problem that we had, because if you are then unauthenticated, there is no mechanism for you to actually get a tenant ID from Keycloak. So in theory, what we have said here is that if you are running the system as a demo system, or if you're running it for exploration purposes or for testing purposes, the system will assume that the tenant ID can be defaulted. And only in this particular instance, so if you do not have a authentication enabled for the system, you won't get a tenant ID, and the system will then assume that the tenant ID is default so that it can meet the minimum requirements for a single tenant implementation of the system. So that was just the one thing that was a little bit of an oddity for us. And that then, let's move beyond that, because obviously that is not the intended way of operation for the system in general. You should always be deploying the system into a production environment as an authenticated system, in which case you should have proper tenant setup. You may only have a single tenant setup, or you have multiple tenants set up, but you will then identify yourself as a user or a application representing that tenant when you engage with any of Tazama's API services. So at this point, you would then do your authentication, and then the Keycloak system will issue what we call the Tazama JWT token that will contain the tenant identifier as a claim or a role to say that you represent that particular tenant. So then every one of these endpoints that we currently have in the system, we would then add the tenant identifier to the message inside the TMS API. As an added measure of security here, we don't want people to be able to pre-provide a tenant ID and then create an opportunity for them to spoof or accidentally use the incorrect tenant ID. The tenant ID that a user will present to the TMS API to authenticate themselves will be issued by Keycloak and only Keycloak. If any user or application tries to access any of our endpoints with a pre-provided or a predefined tenant ID, that transaction will be rejected. Quick pause here if that makes everybody comfortable, or if anybody's unhappy about that. Thank you, Foley. We'll take that as an aye. Okay, so now that you are authenticated with the system, every message that we receive inside the TMS API, we tag with a transaction type, first of all, so that we can identify that specific transaction type downstream inside the system. And what we will now also do is the TMS API itself, and also the associated APIs like the admin service API, and also in the future, a configuration service API. They will add the tenant ID to the message payload as well. So again, no user will have control over that. The message arrives without a tenant ID, and the TMS API will then create a tenant ID attribute inside every message that is received at the TMS API. And again, this is so that we can then identify the message internally in the system as belonging to a specific tenant. And this is going to be very important during the creation of the records in the database. and also later for the routing according to the configurations. So you can have a tenant-specific configuration pack that will be triggered based on the tenant ID in the trigger payload message. And then downstream, every rule processor will use that tenant ID to filter the rule query so that you can only retrieve transactions from the database that relate to the particular tenant. Every data element in the system going forward will be tenant aware. Whether you're single tenant or multi-tenant, every record in the system will be tagged by the tenant ID. Okay. Let me just quickly scan through this. I think there's anything else in particular here. Oh, yes, there was a fairly big change here. In the Tazama data model, we create the keys to identify a particular entity in the data model explicitly through the key, so that you don't have to search for a particular entity or an account in the database. You can address that entity or that account directly in the database, which is better for performance for us. And the keys themselves are also indexed. So once again, that gives us improved performance. At the moment in the system, we have to create composite keys to be able to create a unique identity for someone. So for example, if you consider that somebody is identified by, for example, a social security number, but social security number schemas can exist in multiple territories, you could, in theory, have a duplicate identifier for an entity. So what you need to add to that is a additional subtype for that identifier to say that this was the issuing authority for a particular social security number, so that I can say that social security numbers that may be the same as a social security number somewhere else is now differentiated based on the issuing authority of that social security number, because we at least assume that the issuing authority would issue unique social security numbers. And that is typically a safe assumption unless you're a South African.
Yeah. I dealt with that. Yeah, it's a fun issue. Oh.
So where this problem is now slightly worsened is if you have multiple tenants in the system, then my debtor with a specific social security number issued by my authority and your debtor with the same social security number would now end up with a centralized identity or entity in the system. So for us to then properly separate these, we now also have to put the tenant identifier as part of the key that we are creating to uniquely identify the entity, so that those entities can be properly kept separate in the system. Is everybody following the change that we are making there? So we are extending the key that we are using to reference the entities, the debtor and the creditor entities and accounts in the system, with the tenant ID, so that we can still address them with high performance, but keep them completely unique and segregated at the data level. Okay, all of this work is happening inside the TMS API. That is this particular user story here. Is there anybody that can think of anything that we might be missing here? And we try to be as thorough in our review and our impact analysis on the TMS API as we can. If I look at people in the audience, I think that's probably you, Foley. And I don't know if you want me to put you on the spot here to put anything, to pick up anything that we might have missed. But in the interest of disclosure, I did also send these to Foley so that he could have a look at them in his own time. So if there's any feedback, please do let me know. But just anybody else, anything here that is alarming or seems odd? I'll take that as a win. Thank you very much.
Seems
Right.
right.
Yeah, thank you very much, Greg. Okay, so just in addition to this, and I'm not going to go through this in the same kind of excruciating detail, but we do have a lot of our services abstracted to these libraries here. So the FRMS COE lib is in particular a library that handles our interaction with the database. So all of the database queries exist inside the library over here. I think it's this one. No. I think this is the fairly big one. So all of these database queries themselves now also need to be updated to query the database with a tenant ID filter. And also when information is being submitted into the database, all of these functions need to accept a tenant ID parameter so that they can properly tag the transactions that are being loaded into the database itself. So all of these changes need to be made. And then all of the processors that make use of the library will then also have to be updated because the payload or the parameter list for all of these functions are going to change. So these changes are also covered here. One other change that is worth calling out is the inter-services communication protocol that we are currently using, which is protobuf. Protobuf requires you to create a protobuf definition file, which we currently have. This is this file over here. And in addition to what is currently the transaction type, we also want to be able to create the tenant ID as a surface variable. I don't know if that is exactly the right description for that, but it will allow us to access that variable to interrogate the package without fully decoding the entire message. So for example, when the message arrives at the event director needs to be able to look at the transaction type and the tenant ID, but doesn't need any of the other information in the payload. So some of that information can still remain decoded. I don't know if, Fadi, is that an accurate description of how this works? This is a little bit arcane to me.
Good enough, yes. I think it makes sense.
Thank you. I'll take it. Right. So we are extending the protobuf inter-service communication. We're putting this tenant ID as close to the surface as we can, so it's easier to get hold of. Right. And then going down the other services, so the admin service, we currently use the admin service to administer all of the conditions inside the system. So if you are creating conditions for a particular entity, a debtor or a creditor, or a debtor account or a creditor's account, then you would use the administration service to do that. As with the TMS API, any submission that you make to the administration service also needs to be tenant aware. So you will provide your tenant ID and all of the conditions will be tagged by tenant. So if you remember from our earlier discussion, the TMS API will create all of those entities with a key that is composed with the tenant ID. The conditions are also then using that key to address the specific entity and the specific account that belongs to the tenant. One tenant will not be able to block transactions to another tenant's account. As far as the data layer in the system is concerned, the data is fully encapsulated and segregated, so tenants cannot see or interact with another tenant's data. Each tenant will effectively have their own version of a different tenant's customer. What this also means is if I wanted to evaluate a transaction in an ecosystem, so let's consider that the debtor financial services provider is a tenant, the switch itself is a tenant, and the creditor financial services provider is a tenant. What you will end up with when that transaction is being submitted for a transfer is you will actually have 3 instances of that transaction in the system, and they will be fully separate. So the debtor FSP will have its own little ecosystem around that transaction with the debtor, the creditor, the debtor account, and the creditor's account. The switch will have its own version of that transaction with the debtor FSP, the debtor's FSP's creditor, and so on. And then the creditor FSP will have its own instance of that transaction in the ecosystem as well. So in a multi-tenanted environment, each tenant will be responsible for ensuring that their own transaction is ingested and evaluated by Tazama. What this also means is there will be a downstream knock-on impact on performance in the system. In a multi-tenanted environment, the same transaction will effectively be evaluated 3 times for 3 different perspectives. the debtor FSP's perspective, the switcher's perspective, and also the creditor FSP's perspective. Which means that if we are capable of operating at 3,000 evaluations per second, we will be doing only 1,000 evaluations per second because we are evaluating the same transaction 3 times. So that's just also something to be aware of in a multi-tenanted environment. The recommended mitigation for that at the moment is if you actually have a tenant that needs more than 1,000 evaluations per second by themselves, put them in their own instance of Tazama entirely, because they are probably using enough of that hardware and infrastructure by themselves to justify the economies of scale involved. Right, sorry, I distracted myself. Okay, so on the admin service side, very much the same principle. Identify yourself as the tenant. Your data is posted to the database segregated by the tenant ID. And then walking through the system, the event director over here, this is the piece of the system that evaluates the transaction as it comes in and then looks up the transaction type inside the network map and makes a determination about whether or not to evaluate that transaction and how that transaction should be evaluated. So right up front, as we have now already updated the protobuf payload to include the tenant ID, the event director can access the tenant ID to determine which network map to read. So as we discussed in the last time when we came to the TSC, we decided that we will create a fully separate network map per tenant. And the reason for that is I can then update one of those network maps without reloading everybody else's network maps as well. I can fully manage a tenant's network map in isolation without impacting anybody else. What that then means is the network maps themselves will have an additional attribute so that the network map can be retrieved for a particular tenant. Every tenant will have only one active network map in the system at a time, and that network map will have a tenant ID reference so that the event director can look it up. Then when a transaction is received, inside the event director, this network map will be cached, and the network map will then be retrieved from cache based on the tenant ID, as well as then once retrieved, the transaction type will be looked up in that network map as usual. So the big change here for the event director is to be able to retrieve a network map by tenant ID. This also means that inside the event director, we will now be maintaining multiple concurrent versions of, not versions, but instances of the network map. Every tenant will have its own instance of the network map in memory. They will possibly time out independently because every network map has a limited configurable time to live. So after 5 minutes or an hour or however long that setting is, the specific tenant's network map will time out if there has been no new transactions coming through for that particular tenant. And then there is a read-through caching. So if the network map is not in memory, the event director will go and fetch that network map from the database and then load it into memory so that it is faster to respond in the future. Also, immediately up front, the event director, I can't remember, Foley, does the event director read the network map on startup to
Yes.
create the NATS routing? It does, yeah. So at startup, it reads all of the network maps for every tenant and then subscribes to the NATS subjects to which it is going to eventually then route the transaction when it arrives. So that subscription has to happen at startup for the event director, and it now has to interrogate every active network map and not just the original one network map that we'd previously had. Quick pause here. Any questions, comments, feedback, alarm bells? Cool. These are taking a lot quicker to review than they did to write, I'm happy to say. Okay, So after the event director in our workflow, the event director then sends the transaction payload off to the rule plane, where it is evaluated by the event flow processor, if the condition management module is enabled, and also all of the various rule processors. So as an example here, we're going to show you just the one rule processor, but this change has been applied to all of the other rule processors as well, or will be. The user stories have been created, and they all follow basically the same structure here. The biggest change in the system is we are now receiving the tenant ID as part of the incoming data payload. So we have that additional information available. What has to happen is that tenant ID, once it has been made AQL safe, will then be added to every query that is performed by the rule processor as an additional filter to make sure that it only retrieves data that is related to a specific tenant. And then beyond that, the other issue that we needed to deal with is traditionally we have been caching the rule configuration inside the rule processor's node cache, and we've only ever had to accommodate a single rule configuration at a time. We are now going to have to be able to cache multiple parallel instances of the rule configurations per tenant. Every tenant in the system can have their own unique rule configuration. That rule configuration also has to be maintained in cache, has to be read from the database by tenant ID, and then also stored in cache if it has lapsed inside the cache. There's one other thing here that we are going to test maybe as a side effect. So we'd always had the intention of being able to run the same rule processor with multiple different configurations. Now that we are able to cache different versions of a rule configuration at the same time, it is theoretically now also possible for two different tenants to share the same rule processor with two different configurations, or a single tenant to perhaps have two different configurations for the same rule processor. That doesn't solve the problem of the routing or the duplication of results from that rule processor yet, but I think we are a little bit closer and a smaller problem to solve if we wanted to implement that in the future. Then also here, as we saw with the network map, every rule configuration needs a tenant ID identifier so that you could ring fence the selection of that particular configuration out of the database. This is a filter, so every tenant can only interact or retrieve their own configuration from the system. And then adjacent to that, the event flow processor itself functions in the rule plane. So it evaluates every transaction and then checks the database for any conditions associated with that. Quite simply here, when the event flow processor looks up conditions or the condition ecosystem in the database, it needs to filter that by tenant ID. So that's a fairly straightforward change. One of the odd changes that we have here is at the moment, there are three processors in the system that can generate a message that leaves Tazama for some purpose. So for the event flow processor in particular, the event flow processor can generate a blocking instruction if there is a existing blocking condition against the entities involved in the transaction. That blocking instruction is then relayed to the client system via one of Tazama's relay services. And this pattern is also applied in the typology processor. So the typology processor can also issue what is called an interdiction or a blocking instruction. And then finally, the transaction aggregator can commission an alert instruction if there is sufficient evidence of suspicious behavior, and that alert is intended to go to the case management system. In a multi-tenancy implementation, each of the tenants should be able to receive their own unique alerts. So if there's a blocking instruction against one of the tenant's clients for a transaction that the tenant had submitted, there should be a relay service that picks up that particular alert and then routes it to that particular tenant. In order to accommodate that, we are setting up the processor here, the event flow processor, as well as the typology processor and also the TATPROC, with an additional environment variable that defines whether or not the destination for a message is global or if it is tenant specific. So for example, you might actually want to route all of the alerts and interdictions from the system to a central destination. So it doesn't matter who the tenant is, alerts are going to be managed by some sort of routing authority, or it goes to the same case management system or whatever the case may be. So you would only ever need a single relay service that picks up all of the alerts, doesn't matter who the tenant is, and then routes that to a central destination. So that is an option that we are creating here when you set up these processors. But you can also then set up a tenant-specific routing. So every tenant will then receive their own individual alert or interdiction message out of the system. That created a bit of a challenge for us because then we had to decide whether or not we should accommodate some kind of hybrid approach where you could have some tenants who want to centralize, consolidate their alerts, and maybe they're part of a consortium or a group, and then you have a whole bunch of other tenants who want to each receive their own individual alert. The way that we are approaching that at the moment is we are dealing with that through the relay services. So the relay services themselves are point-to-point routers. So if you then want to consolidate a number of alerts or interdictions out of the system, those alerts would then be routed to the same destination by the relay service, not the source processor. So in this case, the event flow processor will send its distributed alerts to the individual relay services, and then some of those relay services may then choose to route it to a central destination. And that moves the decisioning about where a message should be routed then downstream to more configurable approach in the relay services instead of having to code that hybrid approach inside the core processors and then make those processors more complex. Quick pause there if everybody's comfortable with that approach or if anybody has an alternative suggestion.
I think it makes sense.
Thank you, Greg. Alrighty. But again, as always, if anybody thinks of anything later, please do let us know. These things are always open for discussion. Right. Finally, the typology processor. I think this is starting to become a little bit more repetitive. So this leverages some of the concepts that we'd already discussed. A transaction is submitted with the tenant ID in the message payload. Every typology can be tenant specific. So the typology configurations themselves must be retrievable by tenant, must be cached individually inside the typology processor's node cache. I just reminded myself one thing that is missing from here is the typology processors also use valkey to store the interim results for every typology and every rule as it's received. Those caches inside valkey also needs to be keyed by the tenants so that the tenants don't inadvertently retrieve each other's in progress evaluations from cache. Sandy, please remind me to add that to this user story. I'd entirely forgotten about the valkey cache here, I think. And then similarly to what we discussed for the event flow processor, there will be a interdiction destination that could either be global or tenant specific. And if it is tenant specific, it will go to individual relay services, after which you can then consolidate some of those flows into a single destination like a case management system. That is everything in here, I think. And then finally, the transaction aggregation and decisioning processor, very similar to the typology processor, with one additional change, which is going to be a breaking change with anybody who's using this at the moment. The system currently talks about a producer stream, which is now an alternative way of referencing this particular variable in the system to align this with all of the other or the rest of the vocabulary everywhere else. We are going to rename producer stream to alert producer. That would then be the same as interdiction producer, which we use in the typology processor and also in the event flow processor, just so that we can use a common language across these components in the system. So effectively, that's a little bit of technical debt that we're going to eliminate at the same time here. And then the rest of this is basically also the same. Should be using the Valkey cache, that should be tenant specific, and should also be referencing the destination, which is via the relay service, which should also be tenant specific. That is the whirlwind tour of multi-tenancy as implemented or going to be implemented in Tazama. We're currently, the development team is reviewing these, and we will probably start development on this soon. This change will likely result in a version 3.0 of Tazama, because it is a fairly significant and invasive breaking change across the end-to-end flow of the system. So we'll be communicating that with everybody throughout the development process as we proceed. Questions, comments, any concerns, anything that you think we might have missed or that we should be considering, anything to look forward to in the future, out there to the audience? Polly.
Hey, Justice. Yeah, no, it looks good. We've spoken a bit about it last week, but I'll maybe just echo echo it again. Currently, our typology processor subscribes to NATS topics based on the network map on startup. But if you
Yes.
have different network maps per tenant, then
You
how
have to
should
read all of them. So I think it is mentioned here, and sorry, I didn't actually go into that in detail somewhere. All active network configurations must be retrieved from the database based on all of the active network configurations. So you'll have to retrieve all of the active ones for tenant, and then you will have to subscribe to all of the typology endpoints on either side of the typology processor based on the sum of all of those network configurations. So it is a small change, but yes, it's also one of the things that needs to happen here.
Okay, I missed that. Yeah, that's good. And the same would go then for TAPROC and everything else, I guess. Yeah.
TAPROC and also the event director itself. Something that we would like to consider for a future change is at the moment, when we do want to reload a network configuration or a topology configuration or a rule configuration, even for a rule processor, we have to reboot that processor after we have updated the configuration so that the processor can then absorb that new configuration. The originally, when we built the system before we had NATs, every processor in the system was effectively a microservice, and it had its own REST API interface. So you could even do things like a health check against those processors, or you could create endpoints inside those processors that you could easily then use to give instructions to the processor. At the moment, we don't have the same kind of capability via NATs. So we don't have a way to communicate with a running processor during runtime to be able to give it instructions or to check its health. You basically have to check the Kubernetes dashboards to be able to see whether your processor is still running. So one of the things that we do want to consider here, and I think we might have spoken about this previously at a TSC, was how can we actually create some sort of facility to be able to give operational instructions at runtime to a processor that can only be accessed via NATs. And that's maybe something that I want to throw out there to the audience if somebody has any ideas or ways that we could maybe consider doing that. And then just for everybody, NATS is just our implementation or alternative of something like Kafka or RabbitMQ. Foley?
There's no one else's hands on, but yeah, so you could set up a NATS topic per processor. That's something like your configuration service can talk to. And then once it feeds information there, your topology processor will be able to have a couple of different events that it needs to listen to. And then based on that, for example, in this case, if you update the network map, you can let it know, here's a new network map, and then in runtime it can do that, subscribe to the new topics and so forth. So that's probably
That could work.
Yeah.
Could we perhaps do a proof of concept on something like that? Like, for example, just take the Rule 901 processor and stick that additional NATS topic in there and see if we can turn the configure or reload the config in cache or from database.
Yep. Yeah, we can.
Okay, let's see if we can get that to work. Because then if that works there, then we can try that on all of the other processors in the system as well. Cool,
Yep.
thank you. That's a good suggestion. Okay, that brings us to the end of our agenda for today. Anything else from anybody for today that they'd like us to discuss? We have about 13 minutes left, maybe some room. Otherwise, we will see you all again in 2 weeks.
Thanks, Justice.
Thank you.
Cool.
Yeah,
Thank you very much, everybody. Thanks
Thank
for
you.
Thank you.
coming along on the drive-by tour of the tenant update. We'll see you again in 2 weeks.
Cool. Thank you all.
Thanks,
Thanks all.
everybody. Goodbye.
Bye.